So, hello everybody. I think I know most of you. That I'm Aravan Gregory. I'm the chair of the DDI-CDI working group, and we're having this webinar to explain how DDI-CDI fits into the DDI product suite. And this is sort of preparatory to the upcoming vote that has been announced. You probably saw Jared's announcement over the users list or the community list. So the point here is to sort of explain how DDI-CDI, what it does basically, and how it fits into the product suite. And we have a couple of other examples that will be presented by Darren Bell from UKDA and by Hilda Orton from SICT, showing implementations of DDI-CDI that may be of interest. So I'm going to keep going here. If people have questions, we'll, I guess, deal with questions at the end. And so, but if you want to put them in the chat, that'd be great. If people can stay on mute and not have their video on during the presentation, that's probably best. We are recording this, so if you have an issue with that, just be aware and behave accordingly. I think that's everything I need to say housekeeping wise. So I'm just going to start. The outline of what I'm going to talk about is here. Briefly, what we're trying to do with DDI-CDI, a little bit of history, kind of describe basically what CDI is and isn't, and then talk about how it relates to other DDI products, other standards, and then give you an indication of some of the early implementations and tools and projects and documentation and things to expect, and then turn to Darren and Hilda to show you some examples, and we'll have a quick summary. So the idea behind DDI-CDI is to be able to describe some new kinds of data that have become more commonly used within social behavioral economic domain, but and typically coming from outside that domain. And the word domain is a little funny because it can mean discipline, it can mean infrastructure, but the idea is that there's some things that we don't describe historically in DDI that are starting to demand better functionality, more metadata for certain scenarios. And the key scenario there is the ability to integrate that data with traditional social science data. So in some way, the idea behind CDI is to extend the DDI metadata set to provide for sort of integration-ready description of these different kinds of data. And the focus is very much on the data itself, so the variables and even datums, which is kind of a new thing for CDI. And the idea that you should be able to automatically and losslessly restructure that kind of data so that it can be more easily integrated with the data that you have. So to produce analysis data sets in a familiar form, a more DDI-friendly form, if you will. But to have the metadata in hand to be able to do that as automated a way as you can. And that's it's a huge waste of effort, basically manual effort, doing that kind of data integration, and it comes at a big cost. So the idea was to create a metadata structure that would assist with that. Basically, what CDI also has to describe in order to support that are process flows, because in DDI lifecycle, we have the DDI lifecycle, right? The sort of SBE data lifecycle, well supported. Other domains use very, very different lifecycles. And the data flow, knowing where it came from and how it was processed, is an important part of knowing what it is and how it can be integrated. So that's something you also need to be able to describe. So that's part of what we're doing here. We're not looking at data collection. We're not looking at data management. We're not looking at data production. That's not what CDI is focused on. Just be aware of that. And part of the picture here is that we have to be able to work with domain standards that are not DDI. So it's part of the DDI product suite, yes, but part of its purpose is to work with standard metadata coming from outside the SBE domain and things like generic web standards. And I'll get more into that. People may remember the DDI Moving Forward project that began many years ago. And we spent a long time making a very, very large model. And that did not directly translate into a replacement for DDI lifecycle, which was, I guess, what it was originally supposed to be. What we learned in the course of the DDI Moving Forward work was that we didn't need to replace DDI lifecycle because it was a good standard for doing what it does. And with that awareness came a shift of focus. And so what we really wanted to do was to take the moving forward model and select parts of it. And parts of it had already been brought out in DDI lifecycle. But to take those parts like the variable cascade and also some of the new stuff like the datum-oriented focus, and I'll talk a bit more about that, um, and to bring that to market where it was useful for the purposes of supporting integration. And so DDI-CDI is the first product that's been entirely based on what came out of DDI moving forward, but it was not the product that we expected when that initiative started many years ago. So it's a little bit of history there. What we decided we needed was something new, and that's what CDI is really, designed to support different requirements and to extend the capabilities of codebook and life. If I want to dig into those requirements a little bit more, the issues we have with these new data types is that they can be structured very differently. When you look at sensor data or event registers, things like that, they actually have a very regular structure, and it is rectangular, but it is not organized logically the way that traditional unit record data is, and the data that we normally deal with in DDI. When you look at multidimensional data, we can describe tabulations, but we don't describe the kind of data cubes that are common in some domains for things like SDMX data or OLAP, those kinds of things. We have things like big data stores that we need to deal with now that didn't used to be data at all. And so those kinds of structures need to be accommodated in a way that's consistent with the DDI model. We see a lot of non-XML technology in other domains. We like XML, and it's very good for a sort of closed world monolithic standard and the kind of processing that we do. In a lot of other domains, they don't use XML that much. They're more into RDF, they're more into proprietary flat file syntaxes. There are lots of different things out there. And if you want to on-road those with the metadata into something that is compatible with DDI, there's some work that needs to happen there. And the lifecycle is different. I've already sort of said that. Certainly the terminology and the semantics are different. And so there are a bunch of requirements there. Ultimately, what we realized was that DDI-CDI had to be domain agnostic, that we needed to focus on the data and the structural pieces that are universally true, not on the study level metadata that is very domain dependent. DDI-CDI doesn't really do study level information. We leave that to domain standards. We focus on describing the data itself and the process flows. And we realized also that it was very helpful to support sort of generic web standards like SCOS and DCAT. And that's something I think that the DDI community has been kind of aware of for a while with XCOS and so on. But that turned out to be a part of being domain agnostic, was supporting these generic standards that are used in some other domains. And we needed that generic process flow description because you need to be able to know in general where that data is coming from, and it may or may not align with the kind of life cycle that we do support with process description in DDI today. It turns out that those kinds of requirements are identical to those that you see in cross-domain FAIR, which is a topic that I work like at CoData, where that's a big focus for us, and a lot of our interest in DDI is exactly that fairness. And so in terms of cross-domain, these are the issues, right? What we have in DDI-CDI is a model for describing variables, a very concept-rich model, so full variable cascade, looking at representations, looking at a lot of the relationships between things like categories and concepts, universes, populations, unit types, the whole stack. And that is not dissimilar in many ways to what's in lifecycle, because we want to be aligned on that variable cascade model. The idea is that you need to be able to describe variables independent of their use in a specific structure, because the whole point is to show how they travel between structures. There's an additional feature, which you also see in lifecycle, which are links to external semantics. Other domains have their own ontologies and control vocabularies and classifications and whatever they are. And their concept definitions, their variable definitions, their categories are going to be coming from places that we don't necessarily have to provide a structure for. They're already structured and used in those domains. So we want to be able to reference them and pull them in. There's a model here for describing how variables are used in structures. And this is really a key part of DDI-CDI. So we have a description of unit record data, sort of wide data, rectangular data, whatever you want to call it, which is familiar to DDI. But then we also show how the roles that are very similar but significantly different in long data formats, like sensor data or event data, how you describe SDMX style cubes, how those things can be translated into indicators, and then big data, so NoSQL data, really key value, where you have identifiers that might be structured, but really it's just observations and identifiers organized into sort of buckets, and a much less structured form of data. So we have ways of describing all of those things in CDI. And then a generic model for describing process flows. The other thing that we do, and this is kind of new, is connecting datums to their variables and the relationships between variables and between datums. And this is something that emerged as a prime requirement. It's not always necessary for all of your use cases, but sometimes it proves to be extremely valuable, because certain kinds of systems don't operate on the structural descriptions, they just operate directly on the data. And that's something that you find in different cases. So that's something we support. I don't want to go too far down that rat hole. It can get a little complicated. But DDI-CDI is a big model. It's pretty complicated, but it's intended to be implemented in subsets and profiles. And what we've seen thus far is that those profiles actually aren't very big, that you have 30, 40 classes, and that's what you use out of the many possibilities. Now, there could be more complicated implementations. The idea is basically this. Somebody just publishes data, like say a dimensional data set, some aggregates that you want to use as context for a microdata set, right? And they either have a standard metadata expression like SDMX, or maybe they would directly describe it in DDI-CDI, giving you enough metadata that you could take that cube and what you know about it, and based on what's in the DDI-CDI model, automate the translation between that structure and the structure that you might want, like say a wide data file, losslessly, and to do that in a way that does not require manual intervention. Now, there are obviously going to be things you need to do to actually integrate that data with other data that you have. But the point is to provide as much information as you can to support that transformation, including all the structural information. What that really ends up looking like is that you rip the data apart into its component variables and the corresponding datums and reassemble it without losing the meaning by understanding the change in the roles played by different variables. And there will also be, in this kind of a process, processing. Typically, you may have to adjust values or map values and do things like that so that you can actually integrate that data with the other data you have. So there are points where you can cleanly join on it. And that's why you need that process flow description, because you're going to want to describe those processes and where they're operating and what they're doing to support that integration. So what we have as a specification is a UML model, and we express this in canonical XMI, and in fact, a profile of canonical XMI called UCMIS, or UCMIS, which is designed to be optimized for shareability and support in UML tools. But the UML model is the canonical expression of the spec, and then it has a syntax representation in XML, which is in XML schema, and then RDF expressions. And so it's an OWL and RDFS vocabulary, and we provide that in Turtle and JSON-LD syntaxes. The specification itself is designed to be combined with other specifications, and of course DDI things like XCOS and DDI lifecycle and codebook, but also things that are more natively RDF, like DCAT and PROV, and also to work with standards that describe processes. And that might be PROV, but it might be SDTL or VTL or something else. And really any other specification, especially if that's something in RDF that is meant to be combined, which is true of a lot of the current web specs coming out of W3C. What we don't have in DDI-CDI is a replacement for codebook or a replacement for lifecycle. It isn't designed to handle those requirements. And we really don't want people to make the mistake of thinking that CDI is the next great thing, so you can forget lifecycle, replace those systems, forget codebook, replace those systems. That's not going to happen, and it's not the intention. It's not what CDI is for. It is not an XML representation or an RDF representation of human readable documentation at the study level. It doesn't do study level metadata. And because that's not what you need to automate an integration and to document an integration. we assume that other standards like codebook, like lifecycle, will provide that information to the users. And we provide links to it. And I'll talk more about that in a minute. CDI is not a monolithic standard for describing the data lifecycle. You don't manage longitudinal studies with it. You don't do the things that you do with codebook or lifecycle, because that's not what it's for. And it's very important that people understand that it's built to fill different requirements in those specs. To be a little more complete, the idea here is that you should be able to programmatically derive CDI from DDI codebook or DDI lifecycle. And in fact, we already have an implemented DDI codebook to CDI transform, and it works. Pascal Hayus has written that as part of the Postman toolkit. And I don't know whether he's done lifecycle not yet or not, but I believe he will. The process descriptions in CDI can be used directly with DDI codebook or DDI lifecycle metadata. And you'll actually see how that works in the example that Hilda's going to show you. Instrument study descriptions in codebook and lifecycle can be referenced from CDI as appropriate, because we don't have a place to put that information. And the point is to use those standards where that's already stored. The DDI controlled vocabularies are in SCOS, and CDI is designed to work well with SCOS. The idea that you would use those CVs to define semantics is entirely in line with the design. And this is true also, of course, of DDI lifecycle. So it's no different than that, but that compatibility is certainly there. SDTL, SDTH, although that I don't think is official product yet, again, are both very, very compatible with the process flow description, so that a process described in SDTL could be referenced from the process flow along with its inputs and outputs, so you could understand it in context. And that would be a more complete sort of entire business level process flow using SDTL to do the specific processing descriptions. And would work very well. Again, the lifecycle does a similar thing where it describes process for the DDI lifecycle. The idea that you could use SCOS and XCOS, which is the DDI product, for describing classifications and code lists and categories is very much in line with the DDI-CDI design. One of the major implementation profiles we have now is CDIF that does exactly that. They don't use DDI to describe code lists and categories and codes. They use SCOS and XCOS for that natively. And so that alignment with XCOS is more than an alignment, it's actually a direct use. So you can see that DDI-CDI fits very well into the product suite in terms of how it's connected. It's also designed to work with other domain standards because of what it has to do. So if I have things in Darwin Core, for instance, I can take those descriptions of elements, their versions of variables, and map that into DDI-CDI and describe their data sets. We've done that as an exercise. It's possible. Now, could we do that for everything expressible in Darwin Core? I don't know. But I do know that a lot of domain standards have metadata that can be mapped effectively where it describes data. And I think that's an important thing given the nature of the available metadata for some of the data you want to use in practical terms. RDF is designed to allow combination of vocabularies. And so the RDF expression of DDI-CDI takes that into account. It is RDF meant to be used as RDF. And I would even say that I think the RDF implementation syntax will be the primary one for DDI-CDI in the long term. And it's kind of can be used as a common language. One of the examples I'll talk about in a minute is from the UN Statistical Division, where they're taking the disaggregations of the SDG indicators and mapping them from SDMX to DDI-CDI, and then using DDI-CDI as an interim format to populate statistical variables in schema.org with a bunch of extensions as used in Google Data Commons. And it becomes a kind of practical tool in those kinds of flows. And that's part of what it's good for. That's not what is being used in the end. You're consuming it as something else, but it's a way of getting from a non-variable oriented structure into one that is variable oriented. And I think that's kind of important. Here's a picture from the spec. This kind of shows what I've been talking about. I'm not going to talk through this. You can read this in the high-level documentation. But it's just illustrating that DDI-CDI, we expect it to be implemented with these kinds of references to other standards. I'd like to talk a little bit about some of the early implementations now. You're going to see Darren give a demonstration of the UKDA product builder. where they looked at the variables and the structures. And Hilda's going to show you a couple of things, one of which is the EOSC Future ESS Labs integration, which is a cross-domain data integration looking at climate and environment data and the European Social Survey. And those are both important early implementations that gave us a lot of feedback for different parts of CDI. The US Bureau of Labor and Bureau of Labor Statistics, they're different places, both have done implementations with the variable cascade and modeling indicators. And Dan Gilman, I think you were the guy who drove those. I believe you presented that at Eddie last year. Interesting work. We have this case in the UN Statistical Division looking at the disaggregations and working with SDMX and with schema.org. One of the big implementations right now is through the cross-domain interoperability framework, where we had sort of trials of about 11 different domain data sets. And that work is sort of ongoing, but that's created a lot of demand for CDI. It's a minimum profile. It's about 30 classes for looking at long data, wide data, and multidimensional data. And that's been documented and is out there as part of the World Fair deliverables. We are starting to have some tools here. You'll see the field level documentation as part of the spec, but we have a subsetting tool that was funded by the Alliance, so that when you create a community subset, you can actually get a version of the file level documentation, field level documentation that only covers those classes. And I believe they used that at UKDA. Maybe you could say something about that, Darren. Postman, where Pascal Hayus works, has been funding a lot of open source. And one of the things they've done is a thing that's called high value data services, where they're wrapping municipal data available in a proprietary format called Socrata. It's for a bunch of areas in the US. And then that data becomes expressed in DDI-CDI and DDI codebook as choices, so that you can get the data from Socrata, but document it in a standard way, which is kind of nice. In order to do that, there's now a Python library for working with DDI-CDI. And I believe this is in testing right now, but I believe that the release of this is going to be like early next year. And if you know Pascal, you can talk to him about getting access to that and maybe playing with it. But there will be a set of Python libraries for DDI-CDI that I think is quite interesting. We're now meeting with Dataverse. They have a funded project to implement DDI-CDI in Dataverse. And so we're talking to them now about what that's going to consist of and what the requirements are. We've had a couple of meetings, and they're going to be coming to DAGSTRUL next week to talk to us further about that. SICT has done Converter and as part of World Fair, and I think Hilda's going to show you this as well, going from Stata and SPSS to DDI-CDI, and that even has datum level support. There's a thing in the DDI developers group called the Nectar Publisher. You know, it's a play on Nestar, obviously. But what they're doing is spreadsheet to DDI-CDI, and I believe they also support codebook and lifecycle as part of that. The idea is, how do you get these CSV files documented, and how much metadata can you mine out of those formats? And that came out of a CDI tool that was developed in a couple of days in DAGSTRUL. It was really amazing how quick it was to produce that. But that work is ongoing in the DDI developers group. We have, as I mentioned, the STMX to DDI-CDI converter that UNSD did, and that was input to the CDIF, actually. And then we have the ESS Labs process browser that Hilda's going to show you already. I think this is quite a good picture for a 1.0 spec coming from the Alliance. There are a bunch of projects that just got funded in the last European round. There's a thing called Climate Adapt. I think it's about 8 million euros, big project. They're using DDI-CDI to do the data integration for all of the use cases driving that project. There's one that's coastal with shipping data in Portugal. There's a soil consistency and insurance policy project in France. There's a heat and water availability project in Greece. A bunch of really different data sets from different domains. And they asked us to come in because we knew CDI as co-data. So we'll be involved in that project. But that promises to be a real road test for the standard. There's another smaller project that came out of the Oscars for EOSC, looking at X-ray absorption spectroscopy. And this, we presented CDI at an RDA workshop, and this guy came up to us and said, "Can you handle XAS data?" And I was like, "What are you talking about?" And that led ultimately to proposing a project that's been approved, using CDI to mark up spectroscopic data for exchanging with the domains that employ these big XAS spectroscopy machines. Like, they're sort of like super collider kinds of setups, where you have these big devices that produce this data. And then they need to make databases of the spectrum and exchange that with other domains that actually want to understand the chemicals. So that's quite an interesting one. There's a bunch of projects coming up in World Fair that will be looking at medical and clinical data, climate data, life sciences, hard sciences. We don't even know what all those projects are now, but there are a lot of different things being considered right now. I'm not even sure I'm aware of all of what they are. So there's been a lot of interest, primarily through this sort of fair cross-domain thing. I don't think there's another standard that does what CDI does, and there's a lot of interest in that space. Almost my last slide. I think this might be my last slide. We have a lot of documentation preparation. We have high-level and field-level documentation, which is part of the 1.0 spec. And I mentioned that subsetting tool for community profiles. That link takes you to the full field-level documentation. But we also have some other things in the pipeline. We have a bunch of documents. There's one that really looks at the overall business case for CDI. There's one that Dan Gilman was the editor of about working with other standards. That's nearly complete. We have a couple of documents that aren't as complete. There's a reference profile for RDF that we'd like to put out to support the standard, and then a guide for creating implementation guides, community guides. Those have been substantially worked on, but are not yet finished. And when the spec comes out as a finished product, we'll have to update them. But those are both will be completed in the fairly near term. There's a process within the TC for releasing that kind of documentation that we'll be following. But there's a lot of work that's already gone on, and that will continue. We're also going to have a Git repository, not just for DDI-CDI itself, but also for supporting resources, a separate repository. And we're standing that up now. Akim and Deirdre, I think, are both involved in that work proactively. So there's quite a bit of support planned, as well as the existing documentation that's in the spec. And with that, I'm going to hand over to you, Darren, to show us the UKDA product builder.
Okay, sure. All right, hi everyone. Like Arafan, I think I know most of you, but for those that don't, I work at the UK Data Archive. I'm vice chair of the DDI Scientific Board, and I've sat on the DDI-CDI working group for a while, as well as technical committee. So at the UK Data Archive, a couple of years ago, really, we decided to invest resource and energy into CDI because, as Arafan says, it wasn't immediately obvious whether anything else was around that could do quite the same things at the datum level and being able to represent cross-domain data. Now, I suppose the question that everyone would naturally want to ask is, why would you want to use DDI-CDI? Now, I've heard a few people say, oh, isn't CDI, the next version of DDI? And, I mean, most people here know that's not the case. But for us, CDI complements Lifecycle for very, different purposes. Lifecycle is extremely good at modeling questionnaires and instruments and our study metadata. CDI enables to do something that we wanted to do for a very long time, which is to make it much easier to combine and link data and perform things like real-time disclosure analysis. And I'll come on to how we actually do that in something that we've christened the data product builder. So at the risk of repeating some of the things that Arafan has said, this allows us to model, different data types or data paradigms like multi-dimensional long and key value, as well as the classic wide value survey data. We were working on a smart meter energy data project from 2017 to 2022. And lots of research questions came up, real world research questions that were, around fuel poverty, which wanted to combine climate data, smart meter data, and survey data. So something like CDI already suggests itself as a kind of natural fit to be able to do that kind of data combinations and answering those kinds of research questions. It is naturally, as a DDI product, already integrates nicely with Codebook and Lifecycle for the things you would want to use for in a social sciences specialist repository like questions and instruments. Like I said, it also has the variable cascade. I should point out immediately that Lifecycle also has the variable cascade as well. So the functionality is there as well. But in terms of CDI, what we're able to do here is drill down to the datum and the data point level as well, which is largely for future proofing at the moment, because we're largely working at the variable level. But that variable cascade has a really important function in terms of how we perform linkage. Datum oriented data description, that ultimately is going to allow us to be able to do the most atomic kind of provenance, right from the creation of data through to the dissemination of data. This has kind of always been the destination, right from data modeling starting at the archive decades ago. We're always going to end up at the datum and the data point at some point, and CDI is the thing that kind of finally gets us there. We have the process package in CDI. Hilda will talk about that because Zict have been busy doing some great things with provenance there. And at the digital workshops in the next couple of weeks, we'll be extending CDI out to cope with qualitative types of data as well. So there are lots of classes in CDI. I mean, like there are in Lifecycle. We mainly use the data description package. I'm not going to walk through all of these, but when Arafan talked about profile earlier on, this is effectively the subset of classes that we use within our CDI implementation. There might be a couple of things that have changed over the last couple of years, but this is broadly what we use. The variable cascade. We use identifier components, measures, and attributes, which are really important in determining what types of linkage we have, and then concepts. Now, at the top of this diagram, without getting too bogged down in the detail, you'll see that's a data set. Now, that's actually a wide data set, and that inherits from a generic class called data set. So this model here would, for our purposes, would be equally applicable for long key value and multidimensional as well. So just to give you a few specific examples of how we use some of those classes and for what. The conceptual variable enables kind of initial data set selections in our linkage tool. The represented variable is critically important because that's the thing that tells us what data sets are linkable to what other data sets. And then we have other things like the measure components, which help us drive the UI for data set filtering. So just in the simplest of terms, hopefully in terms that would make sense to a layperson, what our data product builder does, and relying on CDI data to do this, you essentially pick a primary data set, you find that data set by concept, geography, or time. Once you've picked what we call an anchor data set, then using CDI metadata, we can actually show the user what data sets are potentially linkable. This is all kind of blind linkage, so we don't, this is non-disclosive. We allow the researcher to link the target data set with the source data set, and then we allow them to filter that either on cases and variables or rows and columns to normal people. And then once they've got that resulting linked data product, this is the clever bit where we basically allow people to recode variables in real time. And we do that in a guided way so that they can actually in real time reduce the disclosure risk of that data product. And really the use case here is that things that have traditionally taken a long time to get hold of, i.e. sensitive personal data, we can give researchers a kind of version that's not really synthetic data. It's still real data, but it's less toxic, as we sometimes refer to it, so that they can start doing some useful research on that data set while they wait for their application process to go through for secure lab access. So that really, in a nutshell, is what the data product builder is doing. Now, I've got a few screenshots here. I'm not going to run through every single one of these in detail, but in terms of the data sets, a user would pick an anchor data set on the right-hand side. This could be long, wide, multidimensional. Once they've selected that by, selecting geography or concepts, they will then, you can see here, they've picked a teaching data set. and the system will tell you what the potential linkages are. In here, it would be the index of multiple deprivation, linking on the variable LSOA code, which is a geographic variable. Once they've said, yes, I want to link these two data sets together, they will be presented with the different types of variables, whether they're scalar or nominal, and they can elect to filter those, which is essentially reducing the number of cases. It's not immediately obvious, but in real time, we recalculate the number of cases that are available. So here it's 9261. And as they make choices about filtering, that case count will go up or down, which will give them an indication of how much data they're going to get. Now here we've color coded this, which is definitely breaking the accessibility guidelines, but we'll go for it for the moment. You have lower level super output area, and this is actually a potentially disclosive variable. So this is flagging up to the user. They can either throw this out and say, this will reduce the toxicity of this data set, or they can agree to include it, because later on we'll give them some options to reduce the granularity of the data in that variable. So they will then choose which output variables, essentially what columns do I want in this data set. The LSOA code, they've elected not to output here, but that said, there will be a couple of options to reduce the disclosure in the next couple of screens. We give them a preview of the data set, which isn't real data. This is the only bit where we generate some synthetic data for a preview. What we do then is run a disclosure analysis in real time across this. There are lots of kind of 2, 3, 4-way computations we perform on the data, and that results in the user being able to see which variables are making this data set particularly disclosive. So we call them violations, which is, here's a variable which is actually an occupational code. We have an available mitigation, which basically means we can reband this variable. And if we do that, that will take you below the threshold of disclosure, which means that then, having applied that mitigation in real time, you can actually get hold of the data now, where traditionally this would have taken, possibly 2 or 3 months. We would have had to perform linkage for the researcher internally, or got a third party to do it. So, this is kind of the vision, to be able to allow researchers to get a hold of data from multiple domains, multiple types, and reduce the manual administrative layer that currently exists. And it is a real blocker to performing these kinds of linkage operations at speed. So once they've done that, they'll put some minimal DOI metadata on there, and then we'll generate the data product, which they can download. I mean, currently we only do CSV serializations, but ultimately we want to be able to provide, different an assortment of different serializations, as well as the CDI RDF. Okay. So that's what it looks like from the front end. Now, in order to make all of this work, there are 2 major things we have to do. Something we call enhanced curation. Now, the way we frame CDI is that our classic curation, where we take in SPSS, create lifecycle and Collectica repository, all of that is not going to go away. CDI processing is done as a post hoc operation. So from Collectica repository, Deirdre's team take the DDI lifecycle, and the way they do this, we use something called AWS step functions, which is basically an interactive state machine. So we take the lifecycle metadata, we run this through different classifier functions, so that we can enrich that with privacy metadata, conceptual metadata. This is all important stuff that will support the operations in the data product builder. Now, at the end of this state machine, the final thing that happens is that we actually transform the enriched lifecycle metadata. We also inject some kind of SCOS vocabulary metadata into here, and we create the DDI-CDI, and we load that into a very large no-SQL database. Now, RDF can be slow to query and work with. So without getting too technical, we have what's called a graph materialization pattern that we use for our NoSQL database. This allows us to store hundreds of millions of rows of RDF data, but to be able to query it very, very quickly. So on the data product builder now, we can do sub-millisecond calculations in a way we couldn't before when we were using traditional triple stores. I think there's a couple of papers we're going to be publishing next year on this, but it is a very powerful way to store and represent the data. So there's a lot of computational power that's needed to do this enhanced curation. We run all of this on cloud, and currently we spend about $800 a month on this. So it's not, it's not trivial amounts of money, but it's not absurd amounts of money either. So the DDI data sets are, put on that no cloud database. They're optimized for sub-millisecond querying. And we use EC2 instances, which are virtual machines, to do that computation on AWS. We took SDC Micro, which some of you may be aware of, which is originally written in R. Last year, we rewrote large chunks of that in C++ to really optimize that. So that's helped do the computations at speed. So overall, CDI is an important part of our DDI portfolio. It complements Lifecycle. We're still using Codebook, and we may still carry on using Codebook for backward compatibility on the OI feed. But we've been invested in this for 2 years, and really we've got a lot of hopes for this in the next couple of years. The real power of this system is when we can start federating it. So imagine that we could actually query a CDI interface over at Zict, and we could start providing these combinatorial operations between multiple repositories and not just internally to ourselves. And then the world is our oyster at that point. So, okay. All right, so thank you for your attention.
Thanks, Darren. Over to you, Hilda. Hilda, are you there?
Yep, I'm here. Just a second.
Great.
Yeah, thank you very much for your great presentations. It's really interesting to see the data product builder and how things are developed and are working, and it looks really amazing and forward-looking. I'm Hilde Orten. I work at Zict as a metadata specialist here, and I'm also involved with many of the activities of the DDI Alliance. I'm current chair of the scientific board, and I'm involved with different of the working groups. And at Zict, we developed 2 small prototype tools in connection with the 2 EU projects we have been having. And some of it is done by my colleague Benjamin Boestad, also working at Zict. So he is a co-author of this presentation. And the first tool I would like to talk about is the DDI-CDI process description application prototype, or DDI-CDI process 2 web in short. And that is the clickable provenance prototype application, and it covers activities and workflow steps, and also parameters to kind of refer to entities that are used and produced in those steps. And it allows detailed human and machine readable descriptions for these steps, and that provides full transparency of how data have been handled. It uses a subset of the CDI process model that I will show you, a very small one. And the tool was developed by Achim Wacker for Zict under EU's Future Science Project 9, Climate Neutral and Smart Cities. And it is to be enhanced under the upcoming So Green project starting 2025. So what is the background here? We were involved in EU's Future with a science project called Climate Neutral and Smart Cities. And that was about integrating survey responses from the European Social Survey with climate and air quality related context variables. And we took some basic variables about methodology from Copernicus ERA 5 and air quality variables from the European Environmental Agency, and we kind of transformed this into indicators variables related to environmental indices, like, for example, a hot temperature week in front before the interview, rainfall and wind and air quality and so on. So really the process we used was to download first the environmental data, then to marshal them, and then data processing. And that's where the computation of these indicator variables took place. And of course, the purpose of this tool is to capture all this in detail. That allows for fully transparent processes. That is both for verification and for learning, so that experts can go in there and check if the methods and everything we did looks okay, and other people can learn if they would like to do something similar. So this is basically what we use from the CDI process. We use the more high-level activities and sub-activities, and then the step where the variable creation takes place, and also the parameter function that I was talking about. And the basis for what you see in the tool is kind of an XML. And what I would like to say about that is really that we use CDI for this, but it basically points to lifecycle objects, and those are retrieved from the ESS data portal that uses Galactica. There we get some the URIs for those. So this is how it works. And now I would like to show you the tool briefly. Can you see it now? Yes, okay. So the purpose here was to integrate this climate and air quality data with data from the ESS. And for each, we have activities, what is done with the RF5 data, the air quality data. And there are kind of free sub-activities for each. You have the get data, the marshalling, and the data processing. And then when all that is in place, you can do the final integration. So this is basically how it looks. And we could go into one of the variables here to see how it is. So the blue things here are process steps, as you can see in the legend. And here you have kind of the input parameter, or the entities that are used in the production of the output. The output is the new variable. And you can see here, for example, you click on that, and you can go into the data portal with DDI lifecycle to look at then wind gust by date, maximum wind gust by date in the different cities that the project is handling. And also then you can see the steps that went before this step, and what it results in. And you can also, if now this is blocking a little bit, you can also see how the new output parameter are used in further computation. So that is how it works. And you can see here we have a detailed description of the method that is really human readable, a text about how things has been done with little formulas and what is there. And there is also a link to the Python script, so that you can go to the link in the Python script where that takes care of this. So So here you can see there are more. If you're interested and you see this presentation, you can have more information about where you can find the source code and more information about this tool, and also more about that project. Then we have a second one that was done under funding by Welfare, Work Package 6, and that is developed by my colleague Benjamin Boystad here at SIG. It is a Python-based web application. It is designed to convert proprietary tools formats like Stata and SPSS files into DDI-CDI XML files. And Vanneman did this with support from the CDI working group. And this tool also is going to be enhanced further under Fair Impact Work Package 6 to allow for JSON and the DDI-CDI output conformance with SEED. So that will happen now in the coming months. And the purpose here to enhance interoperability in data sharing and standardizing proprietary data formats. And also to support the implementation of CDI and server training. This is a prototype. It's not really for production. And here is how you see the entry pages of the tool. It uses the CDI subset used is 25 classes from the module that I used, but it's going detailed. So also data points and instance values are really included here. And you can import a data file. You see then only the first five rows, like in an SPSS file. But if you download the source code yourself, then you can import as much as you would like. So then you can do things with it more. But here you can see in this view, you have the data view like in SPSS, and also the XML in CDI, and you can download that. It's also possible to switch view to like an SPSS variable view. And here you can see that you are really pointing to instance values here. And you can see here in the XML the instance value, and then you have got that value. Here it is related to a variable called ignore that is normally or usefully could be used as an indicator. And there is a function so that you can define the type of data structure component. If you would like it to be a measure, that is the default. And here you can click in and you can then make it an identifier component. And then you see in the XML that the XML changes. So now you have an identifier component here. It is also possible to click on the links here for the different classes, and then you get into the field level documentation of DDI-CDI. So that is a little tutorial, and you can use that to move a little back and forth between classes there. So this is, I will not go into that tool because I don't think we have time for that, but you have resources. You have the link to the tool here and also to the source code and other output from package 6 of Worldfare. So then I just wanted to say thank you for listening, and I'll stop sharing and hand over to Arhan.
Thank you, Hilda. I have one last slide, two last slides maybe, and then we can take questions. So I kind of want to summarize here. DDI-CDI is designed to do something different than other DDI products, which is to accommodate new types of data and data coming from other domains. It's a domain agnostic standard, which has gotten some attention in the FAIR world, and maybe will bring us some new users. It certainly seems like it will. But it's not a replacement for codebook or lifecycle, and people shouldn't think of it that way. I think it fits really well into the product suite in terms of aligning with and working with other DDI products. And it is more oriented towards RDF and generic web standards than historically we've necessarily done with our products. And also accommodates domain standards. So it's optimized for the use cases it addresses, but in a way that I think is pretty forward-looking and useful. It's been tested in a bunch of early implementations, and we've made changes as a result of that. Very popular in the cross-domain FAIR space, mostly through CDIF. You've seen, a couple of the tools that have sort of been developed here, and there are others, as I showed you. And I think we have good documentation now, and it's going to get a lot better. And so, I guess I'd like to just make a comment to the people who are going to be voting on this, which is, people are going to say, "Oh, I could have done this with DDI lifecycle," and maybe that's even true. But why does that matter? I can open a can of peas with a screwdriver, right? But wouldn't it be better if I had a can opener? And the question isn't, could I have done this with another DDI product? The question is this a good product that does some new things, that is optimized to do new things as part of the overall DDI product suite? And I think the answer to that is pretty convincingly yes. And there are people using CDI that didn't want to use Lifecycle, that didn't want to use Codebook because it wasn't a good fit for their requirements. Nobody forces you to use any part of the DDI product suite, but it's not a competition between the tools we offer. These are complementary, and I think we've done a lot of work to make DDI-CDI complementary to Lifecycle, to Codebook, to XCOS, to SDTL, to the CVs. And so I think that it is a well-designed part of the overall product suite. And if you agree with that, then you should vote yes. So seeing as how it's an election year, I stole somebody's vote yes stuff. But I do, in all seriousness, think that it's not about whether this is competing with other products, because there is, of course, overlap and alignment, but whether CDI does something useful that the community can benefit from and that will enhance the DDI product suite. And I think that's the point. And I think that we've done a good job of that. It's taken a long time, but I think we're there. So on that note, I'd like to take questions. So do we have things in the chat that we should be looking at? Okay, I'm seeing a question from Alicia Nieto Ramos. Do you want to unmute and ask that, or should I just read the question, Alicia? Okay, I'm getting read. Hey, Deidre and Darren, congratulations on your work. I have a question regarding the part where you mentioned you're taking your metadata from DDI Codebook, if I understand correctly, and enriching it with XCOS classifications, and then converting it to DDI-CDI. Is this a Python-based model? Thank you very much. I guess, Darren, you could answer that, or Deidre could, if she's here.
Yeah, I think Deirdre's answered that for me.
Yes, can you hear me, Arfan?
Yes, yes.
Yep, lovely. Yeah, hello, Alicia. Yes, so initially we started off parsing codebook data, but more recently we're using Collectica repository, and we've now got a large part of our collection stored as DDI 3.3, and so we're now. I did notice that the screen was an old screenshot, and it had DDI 1.22, but in fact we are parsing DDI 3.3 now, and combining that with conceptual data. So our conceptual variables are made up of multiple concepts. So we have semantic concepts. So from an else SCOS concepts, and then we also use DPV concepts. So that's the data privacy vocabulary, and that lets us know whether we're dealing with a sensitive data or non-sensitive data. And we also use we're just building in our UK ONS hierarchies, because for the violations and mitigations which Darren talked about, we need to know exactly what hierarchies are in place. So, for example, if there's a particular occupation classification hierarchy, we need to know that this particular concept, that this particular variable is at that level. So we build all of that into the conceptual variable using SCOS.
Based, isn't it, Deirdre?
And it is all completely Python based.
Thanks, Deirdre. Is that a good answer to your question, Alicia? Is that sufficient?
Yes, so first of all, thank you, Rofan, for reading it. I thought my audio was not working, but finally I think it's working pretty okay. So thank you for reading the question. Also, Deirdre, thank you very much for your answer. So everything is Python based, but well, thank you very much. I got that question of the creation part you showed on your slide, but that's perfectly fine. Thank you.
Okay, very good. So Victoria, you're asking about geographic data. Should I just read the question, or do you want to say something more about this?
Yes, we have like in our case we have like geographic data and with social science data, and we have like front catalog for it, and we were thinking about integrating to use the same software for both of them. So if DDI-CDI can like integrate these two formats together.
Well, this is an area that we've looked at, Victoria, and I'm not going to make the claim that we necessarily support everything we need to be honest. But I will say that the support, and partly it's because we support non-wide data formats, honestly. And you see a lot of geographical data held as cube data, right? So in some cases, I think we're much better suited for that application than, say, lifecycle would be. However, like I said, I'm not sure that we have 100% support for this. This is an area that we know we want to look at more, honestly. I think you're going to be at Dagstuhl, if I remember right. So maybe we can sit down and take a look at that use case. We do have specific, a thing called a specialization role in CDI that allows you to identify the things, specific things you're doing with particular geographic variables. And that's not hard coded so that those can be adapted for different systems. So the answer might be yes, but I don't want to say that with full confidence, to be honest. This, like I said, this is an area that I think we would really like to support better. And so let's have that conversation when we have a chance. That's probably not a great answer for your question, but that's really where we are. So.
Thank you.
Okay. Do we have any other questions here? I'm going to take that as a no. And if that is a no, then we're 3 minutes past the hour. And I hope people found this informative. And you know, we have the vote coming up. We're really hoping that the DDI community can turn DDI-CDI into a 1.0 product, because I think there's a lot of demand. We've certainly put a lot of work into it. And I think it's going to be a useful way to sort of extend what DDI does into the modern age and to enlarge our user base in a good way. So if you have further questions about this, please feel free to get in touch with us, and we'll do our best to answer them. So I don't know, I think Wendy, you're somewhere in the audience. Is there anything you want to add from the TC perspective? Is Wendy still with us? No, it looks like we've lost Wendy. Anybody else in TC, or I think anything you need to know about the vote will be coming forward from Jared, right, in future. So, but we're happy to field questions if people have further questions. So, thanks to everybody for attending, and you know, vote yes, basically.
Okay, thanks, Aaron.
All right.